everyone, welcome back. We're going to finish up our Unit 1 review by talking about experimental method, ethics, and statistics. So we know that the experiment is a type of research method, but we're going to do a whole day dedicated to that because there's a lot of important characteristics to know that go into an experiment. So up first of kind of the important things that are contained in an experiment is you need to have a hypothesis. And think back to Piaget's formal operational stage. We said that hypothesis is really important because you're making predictions into the future. You're making that if-then statement. So hypothesis simply is just the if-then kind of prediction based on your research question. So easy thing to kind of note when you're looking at the FRQ prompt, if you're trying to find out what the independent and dependent variables are, typically the independent variable is going to come first, and then the dependent variable will follow, because the independent variable is the thing the researcher is manipulating and changing, and the dependent variable changes as a result. While they might word it weird and it might not always be that way, it's kind of a good rule of thumb. So if independent variable, then dependent variable changes. So an example here is Dr. Sanchez thinks that if students are in a classroom with intense lighting, then they will have improved academic performance. So here, intense lighting is what Dr. Sanchez is manipulating or changing. So that's the independent variable because it's what the researcher changes. And then the then statement is followed by improved academic performance. And that's the dependent variable because it's going to change as a result of that independent variable of the intensity of the lighting. So next key component of an experiment is, like I said, that the researcher is manipulating or changing at least one independent variable. Like you did on that practice FRQ yesterday, kind of being able to explain why something is an experiment or why something isn't an experiment. Probably the best way to do this is by saying that there's manipulation of an independent variable. Other studies cannot do that. Experiment is the only one that can manipulate independent variable and then measure if the dependent variable is changing as a result. And again, that's because there's controlled conditions. You can hopefully make sure that there's no confounding or third variables that are causing the dependent variable to change. You can be certain that it's the independent causing the change in the dependent variable. So again, independent variable is the if, it's what the researcher changes. Dependent is what comes as a result of the researcher changing that independent variable, right? It's the dependent variable because it's dependent on the independent variable. So if the independent variable changes, dependent changes with it. And with this, variables need to be operationally defined. And we said that it's very important to have operational definitions of variables because think back to my little peanut butter and jelly demonstration. If you guys weren't specific and precise in what you were doing in writing out those instructions, it's going to be impossible to replicate your peanut butter and jelly sandwich or your research study if someone else were to do it. So you need to be very specific in how you're measuring your variables or else you can't replicate it. And we know that in order for research to be respected, it needs to be able to be replicated so it's reliable because reliable is doing things and getting the same results multiple times. So operational definition, boom, know this term. It's shown up on the AP exam 6 times in like the past 10 years. So it's super duper important to understand what this is. So fancy definition of operational definition is just the statement of precise procedures that the researcher is going to use in order to measure a specific variable. And typically what AP exam asks you to do is they don't really ask for the independent variable, they ask for the operational definition of the dependent variable. So if you're going to practice knowing the operational definition of the dependent variable. And the key thing that if you're reading a prompt and trying to figure out what the operational definition is, ask yourself this question as you're reading. So first, find your hypothesis, identify the independent. Ask yourself, how is the researcher specifically measuring the dependent variable? Once you have the dependent variable figured out, ask yourself, how is the researcher specifically measuring the independent variable? So let's go back to our example of Dr. Sanchez, who wants to measure the intensity of the lighting in a classroom, um, and how that's going to impact students' academic performance. So she gives students in each condition a 10-point standardized test to complete. What's the independent variable? We said it's intensity of the lighting is what she's changing. Dependent variable is the student's academic performance. And then how are we going to measure this dependent variable? Oh, it looks like she's measuring their academic performance by giving them a 10-point standardized test. So the, again, dependent variable of academic performance, how is that measured? Is it with a ACT? Is it with their GPA? Like, what are you doing? You need to be specific so someone can replicate it if someone else in Ohio wants to do that. So operational definition could be anything like student score on a 10-point standardized test or score of 1 to 10 on standardized test. So be specific in that, right? And another aspect that's really unique just to the research method of an experiment is having a control and experimental group. We know that the control group is just the group that stays the same or does not receive the treatment or independent variable. So, and often the case of like drug trials, this is where they'd receive the placebo or that little kind of fake sugar pill. Or say if you were getting like doing an experiment on caffeine, they would receive decaf coffee, not knowing that it was decaf. So control group stays the same, and then they're going to be used so you can compare the experimental group against them to see how changing that independent variable is changing the experimental group as opposed to the group that didn't have any change in treatment with the independent variable. So the experimental group is the one who is exposed to the treatment or independent variable. Treatment is just kind of the change of the independent variable that is given to them. So oftentimes I like this meme because the little mouse is saying, when you realize the other mouse was in the experimental group. Because oftentimes you wouldn't want to be in the experimental group, especially if you're like a lab rat, because you're getting all the kind of messed up treatment and trials being done to you. But in the case of something like a life-saving drug trial, maybe you would want to be in that experimental group. So it just depends. So then a fourth important component of an experimental design is that you need to be able to control for confounding or third variables. And this is the reason why an experiment is the only research method that can prove cause and effect, that can prove causation. It's because you're able to clearly see that a change in the independent variable results in a change in the dependent variable. And that's because you're controlling for confounding or third variables that are coming in to interfere with that. So a confounding variable is just anything that's an extra variable or anything that's not the independent variable that you didn't account for that's causing a change in the dependent variable. So ideally in a lab experiment, you can control for this and make sure that everything is precisely controlled so nothing besides the independent variable is causing changes in the dependent variable. But sometimes, even if it is an experiment, these things can sneak through. But there's a lot of procedures in place that good psychologists and experimenters use to make sure that these confounding and third variables are not coming in and ruining your experiment. Because if you do have confounding variables, then you can't prove causation because there could be something else that's resulting in the dependent variable changing. So some problems of confounding variables would be something like biased groups. So if people get to pick if they're in the experimental or control group, that's messed up. For example, if you're doing a drug trial and it's a life-saving drug, you might all want to be in that experimental group. Or if the researcher's kind of picking teams, they might say, oh, well, I think these people would be really good in the experimental group, or they're my friends, right? That's bias. That's messed up. And that would, you wouldn't be able to prove causation from that. So to fix this problem of biased groups, you're going to use random assignment. And this is another key characteristic of an experiment. Only an experiment can use random assignment, and that's because only an experiment has the experimental and control groups. Random assignment is just taking the people who are in your sample or the participants in your research study and randomly dividing them up by chance into the experimental group or the control group. So that way it's not biased. Everyone has a fair chance of being in either the control or experimental group. It's just done by chance. So you can use a single and double blind study to control and help prevent confounding variables, multiple different types of confounding variables. So you can use a single and double blind to prevent the placebo effect, because in a single blind, it's the participants who don't know whether they're in the experimental or control group. And then in the double blind, it's also the participants who, again, don't know if they're in the experimental or control group, but also the researcher now doesn't know if they're in the experimental or control group as well. So it's double whammy to prevent confounding variables. Demand characteristics is when participants might figure out the hypothesis of an experiment and try and please the researcher, or they might be very aware that they're being watched, and that kind of social desirability bias of trying to look better because they know they're kind of under the microscope. So again, single and double blind can kind of prevent these as well. And then experimenter bias is when the researcher kind of, they know what they want their hypothesis to be, and they might have an idea of what they are looking for and what the outcome they want from their study to be. So maybe they're trying to prove that vaping's really bad for you. So they're only going to look for evidence that proves that vaping's bad or something like that. So experimenter bias would have that kind of confirmation bias, in which when they're looking at the research and experiment that they're doing, they're only looking at things that are proving their hypothesis. So the double blind can kind of prevent that. And another form of experimenter bias is when, again, they know what they want the outcome to be. So they're kind of conscious or unconsciously pushing their participants to kind of answer in a certain way, or behave in a certain way to kind of prove that hypothesis. So double blind, in which the researcher doesn't know whether they're in the control or experimental group, will help prevent this experimenter bias. So like I said, random assignment, again, just assigning participants to the control or experimental group by chance. And know that this is very important. One, because it's only an experiment that has random assignment, and two, because it helps prevent confounding variables from interfering and ruining your causation. So just to elaborate a bit, placebo effect is the beneficial effect that happens when a person believes they're going to receive a benefit. So the big thing is with medication. So they think that they're receiving a life-saving drug, and therefore they're actually feeling a positive effect, even if they were in the placebo group that didn't, they received like a sugar pill. So it's kind of a psychological effect in that you think something good's going to happen and you almost kind of believe it and feel that way. Demand characteristics, like I said, are when participants form an interpretation of what the hypothesis is or the purpose of the experiment is, and they try to change their behavior to please the researcher. So social desirability bias is kind of like if you're taking a personality quiz or a survey, or just doing anything in an experiment to try and answer and behave in a way that looks favorably upon others. So you're trying to look good, right? You don't want to answer your personality quiz saying that you hate people. You want to look good. Hawthorne effect is when people know they're being watched. So again, you're going to behave better when your manager or boss is watching over you, and behave differently because you know you're being observed and try and please them. So these are things that all mess with causality. And like I said, doing things like random assignment, single, double blind, all can help prevent these things. And like I said, single blind is just when the experimenters know if they're in, the participants are in the control or experimental group, and the participants do not know which group they're in. Double blind is when the participants don't know what group they're in and the experimenters don't know what group they're in. So this covers things like the placebo effect, social desirability bias, demand characteristics, and in addition, adds on the layer of experimenter bias because now the researcher doesn't know what group they're in as well. Okay, so the final important characteristic of a good experimental design is generalizability. So generalizability is very important because you want to make sure that you can take the research results that you work so hard on and now apply it and generalize it to the wider population. So important term to go over real quick is we know population is just the overall kind of population or group of people that you're trying to apply your research to. So it's the bigger group. Your sample is pulled from the population. So you want a representative sample that represents the demographics of your population. So if it's like, 51% women and, whatever the ethnic racial makeup of the population is, you want to make sure that even though your sample isn't going to contain every single bajillion people in the world, that it represents an accurate kind of demographic breakdown of that. So you want a representative sample, right? Oconomowoc, if you're just doing Oconomowoc High School, that's not very representative of the greater population of even Wisconsin, right? We'd be very different than something way up north or something like Milwaukee or Madison. That wouldn't be representative of the whole state. So generalizability, a way to, in addition to having a representative sample, a way to help achieve that generalizability is by using random sampling. So sampling bias is when your sample is not representative of the greater population. So maybe you used Oconomowoc High School as your sample and you're trying to apply it to the whole country. That would be sampling bias. And the solution to sampling bias is using random sampling. And this is just where every member of the greater population, and you're choosing your sample, every member of the population has an equal chance of being a part of that sample. So this can be achieved by doing something like drawing names out of hat. So you have your overall huge population, and now you're going to draw every single name or every single name's included in that hat, and you're going to draw like 20 names out. So every single person has a equal chance of being a part of your study, of being a part of your sample. This is probably difficult to do though. We know random sampling is actually pretty hard because it would be impossible to put the names of every single person in Wisconsin in a hat. So maybe something more like a random name generator online, you're taking the census or something like that. But a perfectly random sample is really, really hard to achieve and sometimes isn't really feasible. But to try and attempt is still important. And it's important to have a representative sample that you can apply to the greater population. So important terms that are easily mixed up. This would be random sampling and random assignment. So random sampling, this is kind of the bigger picture one. So random sampling is, again, you have your population and your sample. Your sample is the little selection from the greater population that's going to be a part of your study. And you want to use random sampling to make sure that every single person in your target population has an equal chance of being chosen and included to be in your sample in your research. And the big thing with random sampling is that it prevents sampling bias and allows for greater generalizability of your research findings. Random assignment, and I should say random sampling is the big thing, is you can use this in any type of study. This could be used in a survey, in correlational research, or it could be used in an experiment. So any kind of research method can use random sampling to choose who's going to be in their study. Random assignment is a unique characteristic of an experiment only. So that's important to know. And random assignment is just giving all participants a chance to be included in the control or experimental group. So random sampling is choosing who's going to be in your study. And then random assignment is now you have those people, they're in your study, and now you're deciding which group they're going to be in. So random sampling's kind of here, then you have random assignment after, kind of smaller. And random assignment is important because it helps prevent confounding variables and experimenter bias. Okay, so let's take a break and look at an old AP exam. So this is the one that we did yesterday, and I just wanted to point out an example of why it's good to know the key characteristics of each research method, especially knowing what makes an experiment unique. And I went over the difference of random assignment versus random sampling, and we know that random assignment is a very important characteristic of only an experiment, because only an experiment has the control and experimental groups. So when you guys on point 9 were asked to give the key characteristics of an experiment and apply it to this vitamin J research on medicine memory, something you could say is that they might do random assignment of participants to the different control and experimental conditions on their research with vitamin J and memory. So maybe the control group would receive vitamin J or wouldn't receive vitamin J. But you can clearly see here that it says do not accept random sampling as a synonym for random assignment. So it's very important that you guys know the difference and make sure you're looking over yourself on AP exam day, that you're not accidentally putting that, because that would not give you a point then, and that would be sad. So to practice, this is what I showed in class when I originally taught this, but I think it's the best example to put all these things together to a real life scenario, or as close to real life as possible. So you can look at this Grey's Anatomy example, watch it, and look for the different examples of experimental design that I just talked about. So pause that and look at that. And then here, just to go over it, so we see a lot of different things. We see Meredith saying, we just pray that the placebo effect is real for people. Why'd she say that? It's because the placebo effect gives that positive effect to people. So when they believe that they're taking a life-saving medication, even if they actually aren't and they're in the placebo group, it's going to potentially give them positive benefits because they think they're getting the life-saving medicine. It's kind of that psychological result and phenomenon of the placebo effect. You see random assignment going on in this Alzheimer's study because the participants were randomly assigned by chance to either the control or experimental group, right? The researcher isn't picking teams and putting people, picking their favorites and putting them in the experimental group, right? It's all completely random and up to chance. The experiment was double blind up until a point. So both the doctors and the experimenters and the participants in the study didn't know who was in the control or the experimental group receiving that Alzheimer's drug. But it remains double blind up until the point when they inject them in the surgery with that medication, because they open the envelope and they have to see. The doctors then have to know who has that, the drug, who's in the control and who's in the experimental group, in case someone that was receiving the drug treatment had an adverse reaction to it. So at that point, it becomes single blind, because now the doctors, the researchers know which groups the people are in, but the participants still do not know which group they're in. So it's a single blind study. So because Meredith ruined the random assignment, this now would act as kind of a confounding variable and could potentially ruin their ability to take their results and prove causation. So I think you guys are totally good with ethical guidelines, it seems like, especially when we're talking about with 3 identical strangers. So the Institutional Review Board is just a committee that reviews research proposals, and they make sure that they're following the ethical guidelines laid out by the APA. And we saw lots of unethical studies in the past, and things have improved a lot based on the kind of misfortunes of those. So here's the things that you can ask yourself when you're on an AP exam FRQ. So they're asking, maybe it says, note one ethical violation of this study and maybe say how you could fix it. So you can ask yourself, okay, well, was there informed consent? Were the people informed about what was going on and asked to be a part of the study and actively said yes or no? Was there deception? Were people being lied to? And we know deception and debriefing go together. So anytime there's deception, you must be debriefed about what, at the very end of the experiment, about what the true purpose of the experiment was and what your role was in that experiment. And then was there mental or physical harm? So, right, even if you're not being physically harmed, if you're psychologically going through some kind of trauma, that still would be violating an ethical guideline. Did they maintain participant anonymity, anonymity or confidentiality? And then was there coercion, or did they not have the right to withdraw from the study? So were they kind of forced to stay in it? An example of that is a Stanford prison experiment, which we'll talk about in social psych. They weren't really given the option to leave. So now just to quickly go over some stats. Typically stats shows up more on multiple choice things, but just to make sure in case something does pop up, we'll breeze through this. Two types of statistics are descriptive and inferential. Descriptive, like the name, describes data. Inferential allows you to make predictions based off the data that you got. So descriptive, two kind of categories within that are measures of central tendency and measures of variation. And this is why I said it's really important to know what falls under measures of central tendency and what falls under measures of variation. So important here, measures of central tendency would be mean, so your average, mode, the most frequent result, and then median, which is the one when you and see what comes in the middle when you line them up in order of smallest to largest and cross and find the middle. We saw on our one practice FRQ we did that they asked about the mode. So that could potentially come up on an FRQ. We don't know. So it might be good to know how to calculate that if you just think back to simple math. But we see there's some issues that arise with central tendency, specifically with the mean. So if you have, say, your data is kind of spread out and that, most people are over here. So your mode, your median's over here, but you have these random outliers that are skewing your data. So this is like all the way over here, even though it's one person, they're kind of skewing the data. So now it's telling you that your average is here when clearly most people are in this camp over here. So a better way to do this is by using measures of variation. So know these two types of measures of variation. We have range, which is the difference between the largest and smallest numbers in a set of data. And then standard deviation is the one we talk about a lot, especially when we're talking like intelligence testing scores, which it's a measure of spread. It's how far out numbers are, how far they are from your mean or average. And then inferential is kind of the one that makes predictions, like I said, and it's this question of, can we take this data and now apply it and generalize it to the larger population, right? Because if you can't do that, it's not really worth a whole lot. So a really important key term, ding, 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 to know is statistical significance. So sometimes an FRQ will ask you, what does it mean if the research results are statistically significant here? And when something is statistically significant, it's just the likelihood that the relationship or association, so this is kind of with correlations. It's likely that the relationship between two or more variables is caused by something other than chance. So it's kind of showing that there's a pretty strong relationship here, and it seems like it's not just a fluke or a chance thing that these are connected with one another. There's probably some more meaningful connection. So if something is statistically significant, it means that the results are likely not due to chance. And if something is not statistically significant, it means that it probably was due to chance and that there isn't that much of a meaningful relationship there. So that's an important term to know. And these are some good videos that talk about standard deviation here. This is some practice problems you can go through. And then just kind of reviewing, this is what I use for intelligence unit, reviewing through some stats. We know the mean here is 100 for IQ scores in the middle. And then this is the normal curve. And what measure of variation can we now use off this distribution, right? This is standard deviation when you're looking at this bell curve type thing here. We know the mean is 100. And let's go down here. So if you can look, just each little kind of bar is one standard deviation. So if you're trying to figure, they're asking you what's one standard deviation according to the graph, like look and see how much is one bar. What's the difference between 100 and 115? It's 15. So one standard deviation is 15 points. And let's kind of just apply this. So what would an individual need to score one standard deviation below the mean? So what IQ score would they have to have? So the mean's 100 and one standard deviation would be 85. So they'd need to be at 85. I don't even say 85 to score one standard deviation below the mean. And then we have the question of what percentage of scores lie within 70 and 130. So this one would be 95%. And the reason why is if you watch this video, she explains it in a really nice way that I am not a math person and can't do. But we have these different rules, the rule of 68, rule of 95, and rule of 99.7. So we know that between 70 and 130 is going to be 95% of your scores falling there. We know that. That's just kind of a rule of thumb when it comes to stats. And we know that 68% are going to fall in between one standard deviation from the mean. 95% are going to fall within two standard deviations above or below the mean. And then 99.7 are going to fall within three standard deviations, again, above or below the mean. And then one more practice. So if an individual scored 145 on this test, how many standard deviations above average were they? So again, each one of these guys is 1. 15 points is like one standard deviation. So 100 is the average. 145, so 1, 2, 3. So they would be at least 3 standard deviations above that mean. So hopefully that makes sense. One last little practice FRQ. This is from my AP exam throwback. This one was kind of hard too, so I probably repressed that memory. I don't know. But just an example of some of the stuff we covered today on an old AP exam. So you guys aren't going to have to draw bar graphs or things like that because it's online, so yay, I probably panicked when I saw that. But here's an example. They ask you to say explain what statistical significance means in the context of the study. And the answer they're looking for here is that you can say, well, if it is statistically significant, then we know that the results weren't due to chance. But if we see that it isn't statistically significant, then we know that the results were in fact likely due to chance. There's not really a strong relationship between the two. So that's an example. We again see here also some ethical concerns. So why is debriefing necessary in this study? And ideally, you're looking through and reading, and you see, well, they use deception, debriefing. Those go hand in hand. So an easy kind of rule of thumb there as well. All right. Thank you, guys. So go ahead and finish your research methods practice worksheet for Tuesday. So take the weekend, take your time to do that. that's just kind of going through some practice application of kind of this stuff with experiments that we talked about today. Operational definitions, identifying independent, dependent variables. And then make sure you're completing your research methods cheat sheet for class Tuesday. Use the stuff from today's video to help you. And then sign up for Tuesday's Google Hangout. We're going to do a practice, a timed practice FRQ together on Hangouts. So that way we're all in it together. You guys can take the 15 minutes. I'll put my timer on and you write as fast as you can, do it, and then we'll go over the answers together. And then keep working on your units 1 through 3 vocab review for Thursday. Remember, I said you only need to do one example because I don't want you guys to be overly stressed out with that. So awesome. Go team. Keep up the good work. Enjoy your weekend.